we discussed question 3 for A-level Pure Mathematics 3, paper 3, May and June of year 2020. You're given an equation where the angle is a compound angle, tangent of theta plus 60 degrees, and you have tangent of 60 degrees minus theta. You have to express this equation as a quadratic equation in terms of tangent theta, and then to solve it for theta in between 0 and 180 degrees. So for this case, we have the compound angle formula for tangent. We know the tangent of A plus B. This is given by tangent A plus tangent B all over 1 minus tangent A, tangent B. Also, if you have tangent of A minus B, then the compound angle formula is tangent A minus tangent B, all over 1 plus tangent A, tangent B. The equation tangent theta plus 60 degrees is equals 2 plus tangent 60 degrees minus theta. So we are to expand the left side here using the compound angle formula. That would be tangent theta plus tangent 60 degrees all over 1 minus tangent theta, tangent 60 degrees. And you have 2 plus tangent of 60 degrees minus theta can be expanded as tangent 60 degrees minus tangent theta all over 1 plus tangent 60, tangent theta. Tangent 60 degrees is square root of 3. So all these can be replaced with square root of 3. So we know that tangent 60 degree is square root 3. That is also root 3, and root 3. The equation is now tangent theta plus root 3 over 1 minus, we can write root 3 in front of tangent theta, it is neater. And you have 2 plus root 3 minus tangent theta all over 1 plus root 3 tangent theta. To write this as a quadratic equation, you must eliminate the denominator. In order to do that, we can multiply this equation throughout by the product of the denominator. So you have 1 minus root 3 tangent theta, 1 plus root 3 tangent theta. On the left side, you have 1 minus root 3 tangent theta in the denominator. So when you multiply, you have 1 plus root 3 tangent theta, and that is multiplied to the numerator, which is tangent theta plus root 3. On the right side, that 2 has to be multiplied by this entire expression. You have 1 minus root 3 tangent theta, 1 plus root 3 tangent theta. This second term here has a denominator 1 plus root 3 tangent theta. Upon multiplication, the numerator stays root 3 minus tangent theta, and the denominator, you multiply and you have 1 minus root 3 tangent theta. We need to expand. That is the product of two binomials. We have to expand the left side. Upon expansion, when we multiply, we have tangent theta plus root 3 plus root 3 tangent square theta. And then we have root 3, and root 3 is a 3 tangent theta on the left side. Now this expression on the right side here, you have 1 minus root 3 tangent theta, 1 plus root 3 tangent theta. That is a difference of squares. So this difference of squares is just 1 square minus the square of root 3 tangent theta. Now we do know that a minus b, a plus b is a square minus b square. So we have 1 minus the square of the second term, which is 3 tangent square theta. The last part here, we expand as well. So we have root 3 minus root 3, and that would give us a 3 tangent theta minus tangent theta plus root 3 tangent square theta. We need to simplify this. Let's have a look. We have root 3 tangent square, root 3 tangent square, both are positive on the left and on the right. So we can subtract root 3 tangent square on both sides. We also have a positive root 3 and a positive root 3. When we subtract, these are gone as well. What is left on the left side? We have tangent theta plus 3 tangent theta. That is 4 tangent theta on the left. On the right, so we need to distribute this as well. We have 2 minus 6 tangent square theta minus 3 tangent theta minus tangent theta. That is negative 4 tangent theta. Write this as a quadratic equation, so we just move everything over to the left side, and we have 6 tangent square theta. 4 tangent theta plus 4 tangent theta is 8 tangent theta. And then we have minus 2 equals 0. The coefficients are all multiples of 2, so we can divide throughout by 2, giving us 3 tangent square theta plus 4 tangent theta minus 1 equals 0. That would be the quadratic equation that we are asked to find. So we have a quadratic equation in terms of tangent theta, and we need to solve this for theta in between 0 and 180 degrees. Let's move to the next page. So we have 3 tangent square theta plus 4 tangent theta minus 1 equals 0. We need to solve for theta in between 0 and 180 degrees. So the angle theta is either in the first or the second quadrant. This is a quadratic equation. We can try to factor this. The quadratic equation is exactly the same. It's equivalent to 3x squared minus 4x minus 1 equals 0. But if you look at this equation, it cannot be factored. If it cannot be factored, the other alternative is to use the quadratic formula. So you see that A is 3, B is 4, and C is negative 1. And the quadratic formula tangent theta is negative B plus minus square root of B squared minus 4AC all over 2A. So the tangent theta is negative 4 plus minus square root of 4 squared minus 4 times 3 times negative 1 all over 2 times 3. And we have negative 4 plus minus square root of, that should give us a 28 all over 6. Use your calculator to compute the decimal values. And we have 0.2153 or negative 1.5486. So these are the two possible values for tangent. Let's look at the first case where tangent theta is 0.2153. Tangent is positive in either the quadrant 1 or quadrant 3, but because theta is in between 0 and 180 degrees, that alternative is out. We only consider quadrant 1. Theta is given by inverse tangent of 0.2153, and we should get a value of 12.1 degrees. The second value, tangent theta equals negative 1.5486. Tangent is negative in the second and the fourth quadrant, but theta is in between 0 and 180 degrees, quadrant 1 or quadrant 2. Quadrant 4 is out. Your answer should be in quadrant 2. To find a quadrant 2 angle, you need to find a related acute angle. Find the inverse tangent of the positive ratio. So you must use a positive ratio here. And beta is 57.1 degrees. Since theta is in quadrant 2, theta is 180 minus 57.1 degrees. And we have a value of 122.9 degrees. In conclusion, the solution to the quadratic equation is 12.1 degrees or 122.9 degrees.